students, welcome to Science Extension and Module 1, The Foundations of Scientific Thinking. This is video number 6, and we're going to have a little wander through confirmation bias. The learning intention for this video and this section of the first module is for you to evaluate the significance of confirmation bias, including theory dependence of observations. So in this little overview, we're going to try and have a bit of a look at what confirmation bias is, some examples of bias in science and whether science is an objective search for the truth, and then bias and theory-dependent observations and how to avoid bias and theory-dependent observations in research. So as always with these particular videos, there's a number of sources that I've looked at that we're going to pull out a little bit more during class time, but some that you might like to have a look at. We've acquired the very short introduction to philosophy of science now, so that's a little booklet that you can have a look at. Gives a nice summary of some of the key points, and I think it's very valuable for this particular course. But you can also see some of the material I've taken from the overview of confirmation bias in science that was produced by Gwenny Goodfellow and Canfield, and then a few other little articles here that you may want to have a look at, either in a bit of detail or just in an overview. Of course, one of the ways of doing that is to be able to read through the abstract, which is a nice little initial summary that gives you an idea of what the article is about, whether or not you want to explore in more detail. So I guess firstly, what is confirmation bias? Well, there's lots of different ways of defining confirmation bias, and certainly a number of different examples of confirmation bias. Very simply, if we don't seek out objective facts, if we're interpreting information to support a pre-existing belief, only remembering details that support that pre-existing belief, or ignoring information that might challenge your beliefs or create some sort of cognitive dissonance, then these are all examples of confirmation bias. Put simply, confirmation bias is the tendency to look for data that supports rather than rejects the hypotheses or preconceptions that we have already established. Typically, it's done by interpreting the evidence that you collect that is going to confirm your existing beliefs or help to try and support your hypothesis. It also often involves the active rejection or ignoring of data that conflicts with what it is that you already believe. So this means it can have an impact on how we gather information and influences how we interpret and recall information. The effect can be stronger for emotionally charged issues and can be reinforced over time. One of the things we'll look at is how confirmation bias has crept into and now has really a stranglehold on arguments around climate science, particularly in the United States. Self-fulfilling prophecies in research can also lead to distorted results, unnecessary costs, poor decision-making, statistical errors, and wrong conclusions. Sometimes this can simply be a matter of the publish or perish pressure that's placed on researchers to continue to pump out more reports, more scientific research, but it can also be a result perhaps of vested interests if their research is being supported by particular organisations. We know that observations are vital to scientific inquiry, and so any factor that impacts on the accuracy and impartiality of observations may influence the conclusions of those inquiries. In addition, the inferences drawn from observations may be influenced by both confirmation bias and theory-laden observations. In previous videos, we've suggested that science is both tentative and subjective. It doesn't have that absolute truth and relies on objective repetition of experimental detail to replicate a set of observations, and also that peer review process that allows a whole range of different people to look at data, to reproduce experiments and collect their own data and compare them with the experimental results that have been reported. However, with a diversity of cultural, personal, intellectual, and often financial backgrounds, different scientists may approach a similar situation in many different ways, and therefore may come to different conclusions. Is this always confirmation bias? Does it always make someone right and someone else wrong? How does science progress in such situations? Kurd, Cover, and Pinnock described contextual values as norms, preferences, beliefs, and interests that are unrelated to the cognitive aims of science. More subtle examples of contextual values include the preference for theories that conform to widespread, unexamined, and usually false beliefs about gender and race. In short, racial, and sexual bias. So one of the problems we have with confirmation bias is it can exist everywhere and it can have some quite sinister drivers. Chris Lee took a look at some very interesting stories in science in relation to confirmation bias and how to avoid it. One of the interesting stories that he shared is the idea of water memories, something that came from a French researcher, Jacques Benveniste, and he studied the effect of histamines. What he reported in the scientific journal Nature was that the antihistamine reaction got stronger as the histamine solution was diluted to lower and lower concentrations until virtually there was no histamines left in the solution, and yet it still behaved in such a way as to create an antihistamine reaction. His conclusion was that water had a memory of the histamines that were originally in it. Now, Nature published this story, but they were very concerned about some of the findings, and so afterwards a group of researchers went to carry out basically the same experiments that Benveniste had already done. This is the nature and practice of science. Those experiments suggested that there was inadequate blinding. That is, there wasn't a control over which solutions had originally had histamine in them and which ones did not. By knowing which ones were and by being able to have some sort of understanding that these ones were more likely to give a positive result, the researchers had actually influenced the findings, and when those blinds were put in so there was no way of telling which ones were which, the results were much less conclusive. So therefore there can be some effect of seeing what it is that I want to see in science. Confirmation bias promotes various problematic patterns of thinking through several types of biased cognitive processes. And these can include your search for information, the favoring of information that supports the idea that you have pre-existing, the interpretation of information, and that can include data that you have generated yourself, and also recalling specific information in the context of how it supports those views that you've put forward or that hypothesis that you originally postulated. Climate science is probably most famous for its bias interpretation in the United States. 97% of actively publishing climate scientists agree that human activities are causing global warming, and I imagine since those studies were published, it is only stronger. And yet in the United States, public views on climate change tend to polarize along party lines. And you can see some very clear distinctions between Democrats and Republicans in terms of their views about global warming. It's likely not a lack of knowledge or understanding, nor insufficient awareness about the issue that can create some of these statistics. Increasing volume of data and evidence on climate change has been presented to the public on a regular basis, so there's really no excuse for ignorance in this area. Individuals with high scientific literacy and technical reasoning skills are not the most concerned about climate change. Rather, they are the ones among whom polarization is the greatest. People form perceptions of risks or controversial topics in ways that match the group values characteristic of the groups to which they identify. And this is really the nuts and bolts of confirmation bias. Sometimes it is just about group recognition. Maybe not publication bias, but stylistic biases in how climate change articles are written. The most prominent effects often reported in the abstract, while lesser effects tend to be buried within the technical results sections. That these two could have a bit of a contribution towards some variations in statistics. Panucci and Wilkins had a look at how bias might operate in clinical trials, and they found a very large number of different types of biases and some of the ways that they could use to reduce these biases. Now, if this isn't an area of science that you're particularly interested in, it's probably not worth going through all of these in detail. But what you can see, most relevant to us recently, has been all of the information that's come through when the COVID pandemic hit and how science worked. And really, science got a very bad rap, and yet it was done so beautifully during COVID. People don't recognize that science isn't an absolute, and COVID taught us that. We had to work through a lot of ideas. We had to go through some trials. We had to understand the levels of mutation rate that were happening with the virus itself and how some of our methods were initially working and then perhaps not working. We had to change. That's not a flaw of science, that's a strength of science. That science learns from its mistakes, that it recognizes where there are limitations, and that it continues to push the boundaries to try and find better ways of doing things. Clinical trials are always a challenge, and so these sorts of trials can be very, very difficult to keep free from bias. So there are lots and lots of different bias that can creep into clinical trials, and these are just some of the things that have to be considered when these sorts of scientific undertakings are being carried through. So how is confirmation bias going to impact on our experimentation? Well, we need to make sure that the scientific process is collaborative. One of the great things that Barker College does is it not only opens its doors and allows other schools to have a look at and participate in the research that's ongoing, but also encourages students to have a look at the research of previous students and to critique or build upon those. That is an absolute modeling of the scientific process. Look at what somebody else has done, think about maybe where they went and whether or not that has applications in a different area, perhaps where we live, or maybe there's something that they identified as a limitation in their own methodology and where you can add on to that. So being collaborative, being open, being able to use public data sets and to release your data, publishing in places amongst the scientific community where a lot of people can critically evaluate your methods and also the conclusions that you've drawn from your data. When you're generating or examining primary data sets, that you come to your own conclusions, that you don't just get influenced by other conclusions or by other scientists who've said things that went before, but that you're very critical about your own data and about the data that you're analyzing. How are you going to interpret them and why have you reached those particular conclusions? And we also have to have honesty and hypothesis testing. We're going to look at this obviously a little later in this course, but null hypotheses where there is no effect and the alternate hypothesis which says there is a relationship between two variables need to be reported honestly and fairly, and they also need to be tested fairly with controlled, regulated experiments. So right from the get-go, we need to make sure we start questioning our research methods and our sources to obtain information in a deliberate and conscious manner. We need to consider the possibility of beliefs and hypotheses other than our own, which might help us gathering information in a dynamic manner, rather than just a one-sided manner. It's kind of like trying to see both sides of the argument and then where you're going to come down, where your conclusion's going to sit based on sifting through all of the information. Try to be more aware of your own ideas and concepts and truly examine the basis upon which they are founded. Are you carrying some of your own biases? Well, the answer to that is yes, but can you identify them? Do you know where some of your opinions have come from, where some of your foundational beliefs have come from? Do they influence the way you think about certain things? And I'm sure that I'd have to say yes to that too. And of course, in the end, does it really affect scientific research? Well, there's a nice little article that you can look at on nestmate recognition in ants and a nice little critique of this particular experimental procedure. In 2013, an article highlighted the impact of confirmation bias on scientific research. When Van Wilgenberg and Elgar conducted a meta-analysis on nestmate recognition in ants, their survey revealed that only 29% of the sample of 79 studies were conducted blind. These studies were more likely to report aggression amongst nestmates if they were conducted blind than if they were not. Moreover, we found that the effect size between nestmate and non-nestmate treatment means is significantly lower in experiments conducted blind than those in which the colony identity is known. We discussed the implications of the impact of confirmation bias for research that attempts to obtain quantitative syntheses of data from different studies. So what can we conclude from all this? Well, to take some ideas out of the 2019 HSC Science Extension Marking Guidelines, bias can limit the scope of science and negatively affect the objectivity of scientific thinking. Vested interests can also lead to skewed results. And the pressure to publish, publication bias, can also prevent researchers from drawing wide conclusions based on null results, limiting the development of scientific fields. This came from a great question in the 2019 paper, and I think it's a very good one to have a look at. This is one of the sources. There are 3 in total. The question was about analysing the effects of bias on scientific thinking and research. I think it's a great question, and actually, I've given it to you as homework for this week. Good luck.